Hello all, welcome to my YouTube channel. Let us see one example of shear design of beam. So before we proceed, I have some questions for you. For which forces we are designing a beam? For flexor as well as for shear force. Flexor design, we have already seen the flexor design. Now how to design a beam for a shear, right? So these are some examples of shear failures of beam. And that is why the shear design of beam is necessary, right? So this is example. The applied shear is say 138 kilonewton. Now here are some clauses from IS 456. The minimum shear reinforcement for any particular beam in terms of the spacing of reinforcement, SV, that is the spacing of shear reinforcement, ASV, that is the area of stirrups, right? Now the design shear strength of the concrete, that is depend on the percentage of reinforcement, right? What is this? 100 AS upon BD, that is PT, that is percentage of reinforcement. So according to the percentage of reinforcement, the concrete provides the shear resistance, right? So this is the percentage of reinforcement, this is the grade of concrete, and you can determine the design shear strength from this table of IS 456, page number 74, and this one is the maximum shear stress, right? Now let us start example, right? First of all, according to the steps, if you have not seen my previous lecture, please see that lecture, because the steps for the shear design is given in that lecture. So please refer it and start. So starting with this lecture, let us start of step number 1. First of all, we have to calculate the shear resistance, right? The shear resistance is that is equal to shear stress multiplied by the area, right? The applied shear is 138 kilonewton, right? So the maximum allowable shear, that is equal to tau C max into BD, right? So what about the AST, that is the flexor reinforcement, that is 3 numbers of 20 mm diameter bar, so that is equal to 942 mm square, right? So what about the PT, that is equal to 100 AST upon BD, right? So the calculated PT is 0.785, so our value, that is 0.785, that is falls between 0.75 and 1, right? So we have to determine what about the shear resistance by interpolation, right? So let us go for the interpolation. 0.56, our grade of concrete is M20, so that is 0.56 plus the difference between 0.56 and 0.62, that is 0.06, and difference between 0.75 and 1 is 0.25, right? Multiply by our value of PT is 0.795 and the lower value is 0.75, right, is equal to 0.568 Newton per mm square. So our shear stress of the concrete, that is 0.568 Newton per mm square. And let us calculate what about the shear resistance provided by concrete, right? That is equal to tau UC, that is the shear resistance of concrete that we have already determined from this table, and that is 0.568, and our area of beam is 300 mm by 400 mm, right? So the shear resistance that is provided by concrete is 68.16 kilonewton, right? Now what about the next step, what we have to do? So here we have to check whether the minimum shear reinforcement is adequate or not, right? So what about the minimum shear reinforcement according to the code, that is equal to 0.4 B into D. So 0.4 B into D, that is equal to 48 kilonewton, right? So let us check the total shear resistance provided by concrete plus minimum shear reinforcement. So total shear reinforcement provided by concrete is 68.16 plus the minimum shear reinforcement provided by the stirrups, that is 48. So the total shear resistance, that is equal to 116 kilonewton, but our applied shear is 138. So in this case, what happens? Minimum shear reinforcement is not sufficient, so we have to do the shear design, right? So what we'll do in this case, What about the applied shear? That is equal to 138. And what about the shear resistance provided by concrete? That is 68.15. So 138 minus 68.15, that is equal to 69.84. And for this particular force, we have to do the shear design, right? So what we will do, let us see the area of two leg vertical stirrups of 10 mm diameter. The area is 157 mm square, and spacing of stirrups, that is equal to 0.87 into Fi is 250. Grade of stirrups, that is equal to 250, and 157, that is the area of vertical stirrups, multiply by 400, that is the depth of beam. And what about the shear? Shear is 69.84, that have to resist, right, multiply by 1000. So the spacing of stirrup for resisting this particular shear is equal to 195 mm. So we are providing the 10 mm diameter stirrups, about say 200 mm center to center, right? So this is about the shear design of beam, right? Thank you for watching. If you have any doubt, any query, any question, please don't forget to like, share and subscribe. Thank you for watching.